Okay, Geometry, Chapter 5, Section 8, Applying Special Right Triangles. Okay, so pause, try this, and come on back. Okay, give your answer in simplest radical form, and your answer should be 5 square root of 5. In this case, again, the legs are 2 and 3, so 2 squared plus 3 squared, 4 plus 9, 16, so x equals, 13. So square root of 13. C is square root of 13. And simplifying this, we need to rationalize the denominator, multiplying top and bottom by square root of 3, which leaves us with 4 times the square root of 3. Remember, when 12 is over 3, it can be reduced, and so you have that. In this case, are there any perfect squares in the 20? And good. Square root of 5. So today the objective is to apply properties of your isosceles, or your 45, 45, 90 degree triangles, isosceles right triangles, and justify and apply properties of our 30, 60, 90 triangles. So a little bit of background. Think about a square. So as an example, here's a square. The diagonal of a square divides it into two congruent, what kind of isosceles, right? Isosceles right triangles. And since the base angles of an isosceles triangle are congruent, so we'll be looking at that triangle like this, right? This is the base down here, is congruent, then the measure of each acute angle is the same. So these two acute angles are both 45 degrees. So another name for an isosceles right triangle is the 45, 45, 90 right triangle. 45, 45, 90 triangle. And so we could say that this type of triangle is one type of special right triangle. We can use the Pythagorean theorem to find a relationship that's special for the side lengths of this type of triangle, so of a 45, 45, 90 triangle. Okay, so for the isosceles triangle, we have a theorem, or the 45, 45, 90 triangle theorem. In this type of a triangle, both legs are congruent. The hypotenuse, the value of the hypotenuse is really equal to the product of the leg times the square root of 2. So I like to think of it as we have two sides that are congruent in this type of triangle, and so we're multiplying the hypotenuse by square root of 2. L square root of 2. Okay? So let's see how we use this in this example. We're finding x. So when we're given this much information, if we know we have a right angle and then one of the two remaining angles is 45, what can we then say about the unknown angle? It's 45, good. So we know that we have an isosceles right triangle, so this second leg equals 8, and we don't even have to use the Pythagorean theorem. We can simply use what we know from the 45, 45, 90 theorem. X equals 8 times the square root of 2. Good. And go ahead and see if you can answer this question. This is slightly different. In this case, we know the value of the hypotenuse. Okay? So we could say that 5 equals what? Based on the fact that we see these two legs are both x, and this is a 90-degree angle. This is a isosceles right triangle. So the hypotenuse 5 equals equals x times the square root of 2. So set that equation up, and it looks like this, right? Based on our hypotenuse equaling a leg times the square root of 2. And now we simply solve for the one unknown. If you would like, pause, come on back. And when you do, we're going to take and divide both sides by square root of 2. Now don't forget, we can't leave it this way. We've got to rationalize the denominator. And when we do, we multiply top and bottom by square root of 2. Oops, what did I do? I just erased the entire thing. There you go. let's see if I can delete the right thing. And we end up with 5 square root of 2 over 2. And we can leave it in that simplified radical form. It looks beautiful. Okay, let's try it again. Pause the video, come on back. In this case, this is kind of fun. One leg in this isosceles right triangle is 10 times the square root of 2. If we want to find the unknown x, which is the hypotenuse, we will multiply the leg times what? Very good. And it's kind of cool when we multiply square root of 2 times square root of 2, we're squaring the square root of 2, right? And so we end up with the value square root of 2 squared is 2, and 2 times 10 is 20. Very good. Very cool. Very fun. Okay, try it again and come back and check your answer. Welcome back. Again, we identify here that we have an isosceles right triangle, 45, 45, 90. Therefore, this 16 equals 2 times what? The square root of 2. I'm sorry, equals x times the square root of 2. I keep saying 2 too many times. And so now we are going to simplify or solve for x, divide both sides by square root of 2, and we must rationalize this, right? Get that square root of 2 out of there. When we do, we multiply top and bottom by square root of 2, and we end up with 16 times the square root of 2 over 2. So 16 could then be divided by 2, giving us 8 times the square root of 2. Good job. Okay, here's a real world example. Jana is cutting a square of material for a tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches so it will hang over. So we want to make it a little bigger. Hang over the edges of the table. What size square should Jana cut to make the tablecloth? Round to the nearest inch. Okay, so now we're not just going to leave it in radical form, we're rounding to the nearest inch. Okay, so first we want to say she needs to create a 45, 45, 90 triangle with a hypotenuse that is slightly different than the diagonal of the table, 36, right? The hypotenuse needs to be 36 plus 10. She wants the diagonal to have an additional 10 inches. So the hypotenuse now has 46 inches. We know that. So what size square should she cut? We have this hypotenuse of 46. Let's find what one side would equal. Therefore, we have the 46 equals a side times square root of 2. Solving again, just as we've done before. Divide both sides. And when you divide and round that, we get approximately 33 inches. Good. Okay, our second theorem today is look at the degrees in this triangle. It's the 30, 60, 90 triangle. 30, 60, 90 triangle, if we look at the length of the sides, each side is a different length, isn't it? So we have what type of, how could we classify this triangle on the basis of its side lengths? Scalene. Good. So this is a scalene triangle. It is a right triangle. So would the Pythagorean theorem work to find a missing side of this triangle? Yes, it would. And so in this type of a triangle, because it's commonly found in real-world applications, the discovery was that the smallest side of this type of triangle, let's say it has a length of s, has a special relationship with the other sides. It's very interesting. If you know the smallest side, s, then you know the length of the hypotenuse is twice the s. The length of the hypotenuse is twice the s. And the middle length leg, it equals s times the square root of 3. And the way that I remember that is that it is a scalene triangle, so there are 3 different length sides, right? And so what number is inside of the radical? 3. Okay, so that might help you. I don't know. It's the way that I remembered that. Okay, so let's use what we know about the 30, 60, 90 in this example. Pause the video and come on back. Okay, we've been given the hypotenuse length. So we know that the hypotenuse equals 2 times the shortest leg. Which variable represents the shortest leg? X. So we could say that 22 equals 2 x's, right? And now when we divide by 2, we know that x equals 11. Good. Now that we have the shortest side, we can deal with the middle leg, right? The middle length leg, y. And if you recall, y equals the shortest side, which is 11, times the square root of 3, right? Scaling 3. So we would say 11 times the square root of 3 equals the longer leg, or the middle length side, right? And so there we have it in radical form, and we are not being asked to give it in decimal form, so that's probably just fine. Okay, we can do this again. This time we have a triangle, and we know the longer of the two legs. So 15 equals what, given our 30, 60, 90 theorem? 15 equals, in this case, x times the square root of 3. Okay, so we can find x if we set it up that way, right? And so what will we do to find? Divide by square root of 3. We'll have to rationalize the denominator, multiplying top and bottom by square root of 3, right? When we do, the square root, or the denominator becomes 3, which is a divisor of 15, right? So simplify 15 over 3 when you do that, and you end up with 5 times the square root of 3. Good. Now that we have that, that is x. We can find y. Remember, y is just equal to 2 x's. Good. So we're just going to multiply 5 square root of 3 times 2. And when we do, we end up with 10 times the square root of 3. Good. And we have one last example. I'm just going to let you solve this on your own. Come on back and check your work. Okay, welcome back. And you may pause it and check your work with this answer. Very good. And now one final real-world example. A manufacturer wants to make a larger clock with a height of 30 centimeters. What is the length of each side of the frame? Round to the nearest tenth. A height of 30 centimeters. Okay, so here we have a 30, 60, so we have a 30, 60, 90 triangle, right? Okay, so this clock is an interesting shape. It's triangular, but anyway, the height here is given 30 centimeters. And so we can say that the height of the triangle is the length of the longer leg on a 30, 60, 90. So to find x of the shorter leg, x or the shorter leg, when we have a given 30 height here, or we have the longer leg. To find x, we can say that the middle leg, h, 30, equals what? It equals x times the square root of 3, right? So now we can find the shorter leg by simplifying this, or solving this equation. And when we do, we rationalize, and we get 10 times the square root of 3, right? That's the shorter leg, x. Looking back here, that's this value here. In order to find the hypotenuse, we know that the hypotenuse, y, equals 2x. So we simply take x, substitute, and so we end up with 20 times the square root of 3, or 34.6 centimeters. Try the quiz, come back and check your work. Okay, it was a square with a diagonal of 20. Remember, that is now our 45-degree isosceles triangle, right? So if we know the diagonal, we have 20 equals a side times the square root of 2. Solve that, and you get 40 square root of 2. Okay, and that equals about 200 centimeters. An equilateral triangle with a height of 24. Oh, by the way, we had to find the perimeter, right? The perimeter, so you had to multiply that by 4. This is an equilateral triangle, so we'll multiply it by 3, right? And we get the answer. Good. We only have a few seconds left. Oh, I'm sorry, I skipped part 1. So part 1, let me just show you the answers real quick. Hopefully you matched up. If not, come and ask me a question. There you go. We're almost out of time. So let me give you your assignment. And there you go. Have a good time.